Welcome back. So I'm going to talk a bit about the question as to whether security practices in open source are robust enough for cloud computing today. And let me give a bit of background about the talk. I'm not going to talk about me. You can find me afterwards. So the idea for that talk came about at the beginning of the year when I chatted to some people of the Linux Foundation who were working for the Core Infrastructure Initiative. And we sort of realized there's very little best practice around these days. I tried to condense like an hour talk into 20 minutes. So it's a lot of stuff I would talk in it 1 hour is sort of cut out. But if there's bits you want to know more about, come to me afterwards. For this audience, really, I guess the key question is what is OpenNebula doing or not doing, and maybe you need to have a discussion within the community about that. So just to set the scene a little bit, fundamentally, software bugs happen. There's no way around it, and some of them will be security vulnerabilities. And the way how I tend to think about them is really using a zombie analogy, right? Software vulnerability is fundamentally a weakness in your software, and the hackers are trying to break your system. They're your zombies, and that will sort of run a little bit through that presentation in terms of imagery and analogies and so on. So to just set the scene a bit, right? Because I'm going to introduce a couple of models for processes. So here you'll see a timeline, and at some point, a vulnerability gets introduced. This is supposed to be a picture of like a broken glass pane in a window, to go back to the zombie analogy. So it's introduced, and at some point, somebody will discover that vulnerability. Could be a good guy or a bad guy. Right? If it's a bad guy, there's very little you can do. They might just sell the details and hack into your system and so on and so forth. So we're not going to talk about that. What I did want to talk about a little bit is, as a project, really you need to have a mechanism to encourage people to report vulnerabilities to you via your security@your-project email address. And looking at that, in a bit more detail, you have to realize that fundamentally, the discoverer of bugs are really in control. There's nothing, you can do to stop them to do whatever, they want to do with that information. You could just encourage them to work with you. So, coming towards processes, right? I think about vulnerability management processes fundamentally, as a team effort in your community, with your users and other stakeholders, to basically ensure that all the doors, windows, any weaknesses you know about get closed and addressed as quickly as possible. And really, the reason why you want to do this is because you don't want to have the zombies run around in your data center, right? So let's look at a few patterns, because I will need some of the terminology a little bit later. So the first pattern is full disclosure. Who doesn't know how this works? All right, so I'm going to zoom quickly over it. So very quickly, bug gets reported, there's going to be some triage, and then it's going to be announced to the world. Then you have this phase where your open source community or your project is going to scramble and try and find a fix. They will also do things, like maybe get CVE numbers assigned, validate the fix, and so on and so forth. And then fundamentally, the fix is released to the world. And in that model of full disclosure, you're really running against the clock. And then, the fix is available, and your users can deploy that, and then you basically lost control of the process at this point. It depends on when and how they, upgrade their systems. The second model is what we call responsible disclosure, which seems to be the predominant model today. And that is slightly different, right? So again, we have, and the colors are actually relevant here. So yellow means it's your project security team. So your bug gets reported, there's going to be some triage, the fix is developed in private, and at the end of that process, it's fundamentally disclosed to a pre-disclosure list, which is different to announcing it to the world. What you might do in parallel is get a CV number allocated, look at whether there are workarounds and all sorts of things to improve your description of the issue, which gets pre-disclosed with the bug in the patch. Then you have a period, which I call a pre-disclosure period, where a number of privileged stakeholders in your community, and it might be distros, that might be users or whatever, get to see that information to upgrade their systems or do something with that. And after a set period, the issue gets announced to the world, and there is an interest. We said it was secretly handled, and ideally, you don't really want this period to be longer than 2 or 3 weeks. Otherwise, you might sit on it for months, and there's lots of examples around there. There was a recent Apple vulnerability where they didn't fix it for 6 months. A lot of proprietary vendors, have months where they sit on issues, and it gives the whole responsible disclosure process a bad name, which is why a lot of people don't like that approach. And then, fix is released, it goes out to the world, people patch your system. So I wanted you to just briefly hold the thought, because we'll get back to that later, because fundamentally, there's a lot of different ways of how things can play out in the pre-disclosure period. So we've done the terminology. So I briefly wanted to discuss a few examples, just list a few examples of what different projects do. So full disclosure. So if you look at the Linux kernel, there's actually the OSS security list, and a lot of projects use that. You post your issue there. It's publicly available for everyone to see. The Linux kernel also has security at kernel.org. They have like a 5 days period where they try and find a patch, and then it goes out publicly. And then a lot of projects like OpenStack, QEMU, and many others use full disclosure for low impact issues when they're not really that severe. Then I have what I call the responsible disclosure model for distros. I'll explain how this works later. And that's basically what the Linux kernel uses if you use OSS security distros. That's very different to this list, and a lot of people who are not familiar with this have by mistake sent stuff to there when they actually meant to send it there, and it went out to the world. Even Google and a few other big organizations have fallen foul of that. Linux distributions tend to follow that model, and then also many other projects like QEMU, libvirt, overt, long list. Then we have what I call the responsible disclosure cloud model, and this is used by OpenStack for intermediate to high issues. It's also used by OpenNFV and OpenDaylight. They basically just copied the OpenStack process. And also, Xen Project uses this model. And I'll explain some more things about this later. And then comes the really boring part, which is why I put them in orange. A lot of projects actually don't have a clearly stated process. For example, Docker states they follow responsible disclosure, but if you try to dig into it, you can't find any information. And the same is true for Cloud Foundry, CoreOS, Kubernetes, and many of these other projects. But what most of them do have in common is that you can actually report issues. What was interesting, Kubernetes, when I gave this talk originally in August, they didn't have a way to report issues, and then somebody of their guys was sitting in the audience, and then a week later they actually had an address available on the website to check. So, question, what does OpenNebula do, right? I couldn't find anything, so I'm going to put you into this bucket, and you may want to have a discussion about that later. So let me just look in a bit more detail what the difference between the distro and the cloud model is. Now, I made up these terms because there's no real language today which allows you, to describe those different models. So remember, I asked you to hold in your mind, the idea that different things can happen during this pre-disclosure period. And really, the two main changes, the two main dimensions where this happens is what can you do with the information which gets shared with you, and who are the people who get that information. And those two things very much depend on what do you want to get out of this process? What are your goals? Let's just look at a few common goals. The first one is obviously you want to ensure that a fix is available before the world starts knowing about it. Very common. That's what every project should have. Then another goal, which is very common, is to basically ensure the downstream projects. So, for example, if you look at Linux and Linux distros, the Linux distros basically take a fix, package it up, and test it in their environment, and they know it all works. Then we have sort of more newer goals, right? For example, you may want to allow a service provider to plan upgrading their service during that pre-disclosure period. The rationale behind that is that if you run at cloud scale, it might take you 5 days or so to just plan everything. You may have to notify your customers. You have to make sure that all the staff is there. You have to do a lot of internal testing and validation and so on and so forth. And you could go further. You may even allow service providers to upgrade their systems during that period, such that when the bug is publicly announced, that actually the system has been patched. So at this stage, let me just talk a little bit about what the Xen Project does here. So for us, we fulfill all those 4 goals. We allow service providers, as well as distros, on a pre-disclosure list. We don't discriminate against them according to size. That has some trade-offs, which I'll cover a little bit later. So right now, we have about 50 different organizations on a pre-disclosure list, which is very large for a pre-disclosure list. Typically, they're around 6, 7, maybe. We have a public application process with very fixed criteria, and overall, a 3-week period from the bug being identified to the announcement, to the public announcement. So this structure already gives you the definition, of those 2 models, right? So basically, your first 2 goals, making sure that a fix is available and that distros can basically package and test it, I call that the distro model. And if you want to have those further goals around service providers, I call that the cloud model. Basically, just such that we have a way to label those 2 different approaches. Now, it's actually interesting if you dig into this a little bit deeper, right? The distro model of pre-disclosure really emerged before cloud computing. And what's noticeable there is that actually services and their users are really, they're treated like any other user. And for that reason, they don't have the information that a bug is there, until everybody else has it. And there's a few things to consider. Service providers tend to be high-value targets, and that may mean, and as soon as that information goes out, everybody will try and break them. And if you have millions of users, then of course the impact potentially might be very huge. Now, in the cloud model, which emerged recently, and I think that's sort of fundamentally been pioneered by the Xen Project as well as OpenStack, we've basically worked with service providers to make sure that this doesn't happen. There are a lot of stories around it. In Xen's history, it took us 3 years to get to this point, which was really a series of, well, experiences and, well, not really disasters, but lessons we learned, and then we iteratively improved the process. And there's some really, really interesting stories about it. If you want to hear them, find me later. Now, those two models really have trade-offs. First one, we covered it already a little bit, is risks for users, right? So cloud services, particularly at scale, have lots of users. So as a project, you have to make the decision, how important are those users, and how many are those relative to direct users of your project. If you don't have a project which targets cloud, then maybe you don't need to think about that, and a distro model is fine for you. Another one is risk to your project's reputation. So let me tell you a little bit of a story. So I don't know whether you remember, in October 2014, Amazon, Rackspace, SoftLayer, and a few others basically had to reboot their clouds because of a Xen vulnerability. And then there was a similar instance in March 2015 where they all announced they would have to do that, but AWS in the end then didn't have to do it because they developed some live patching capability around the time. What was really interesting is we got really slaughtered, by the press, for this, and that was just, because users were fundamentally inconvenienced, right? The users of those services were actually never put at risk because all the patching happened before the information went out, but there was a degree of inconvenience, and it was a really huge story, in the press. Just imagine what would have happened if actually, users were put at risk. It could have killed the project, fundamentally. And that applies to Xen, and it applies to many other projects as well. I'm running out. I have about 6, 7 more slides, so I'll be fine. The other one is risk of information leakage. So if you look at your pre-disclosure list membership, I already mentioned, the more people you have on it, the more risk there is that somebody might leak that information to someone and does something with it. And that kind of gives you the rationale why very conservative people tend to go for the distro model because the risk is lower. The way how we look at this is fundamentally, if somebody leaked an issue, we would immediately release the information, and then the person or organization who does it gets pushed off the list. So there's a sanction there. And in 2 years of running things that way, we never actually had an issue. There's a question of fairness, right? To reduce the risk of leakage, you could restrict your pre-disclosure list membership. You could basically say, well, I'm only going to allow, for example, large service providers to be on that list. Or I could have a very opaque application process where it's not clear under which circumstances you qualify. And there's a lot of other different ways of how you could do that. What's interesting, this is what we did in the early days. Xen only allowed large service providers. This is what OpenStack does today. At the end of the day, that creates issues of fairness, and you really need to decide as a community, what values are important for you. So coming back to the original question, are security practices robust enough for the cloud? I think the answer is no, which is kind of why I put the Jenga stack up there, and I'm going to explain a little bit about this now. So if you look at software stacks today, software stacks get more and more complex, different layers. Each layer might be a project which has a different security vulnerability process and also a different approach. And so you have that whole idea of a weak link, right? So if something in your stack, doesn't have any process, that's your weak link. Fundamentally, as a user of that stack, you're basically going to be vulnerable because of that weak link. The good news is best practice appears to be emerging. But what's interesting is older projects, which have relevance in the cloud, they're not really discussing change today. And the newer projects don't really build security management into their culture from the beginning, and then later on it becomes very, very hard to change. And a relatively new problem is media hype. Now as a project you have to do all of this under the scrutiny of the media. For Xen, for example, every single time there's a vulnerability out there, there's a register story or some story, even if it's a totally stupid vulnerability which isn't branded and which really affects nobody. Even when we do a point release and we just list a number of vulnerabilities which we fixed, there might be a story, right? So again, comes back to the reputation. Last few slides, and then I'm going to questions. I think what's really important is that small differences in those processes actually can have big consequences. I'm just picking out two. One, for example, is should you assign a CVE number or not? And not all projects create CVE numbers for all of their vulnerabilities. Some don't at all. And I just wanted to kind of show you, what the impact is. There's actually databases which can be used to evaluate your project. There was actually a very interesting talk at OSCON where a large vendor made the case that open source software is more secure based on data in those databases than proprietary software. But actually, it's not taking account of the fact that different projects and products may have different assumptions. So, for example, if you look at this graph, right, this shows Xen vulnerabilities from 2007 to 2015, which had CVE numbers. Actually, you could you could think that maybe we became a lot less secure. But actually, what really happened is, at that point, we introduced a process which required us to assign CVE numbers, for every vulnerability. And, it becomes even worse if you compare different projects. Another example is disclosure times. First observation is long disclosure times are bad. They discredit this whole process. And if you choose shorter disclosure times, you actually have to make sure that it satisfies your goals, right? You have to be able to deal with issues in a timely manner. So, for example, we do, for example, a week to prepare a fix and then 2 weeks for vendors to upgrade. In OpenStack, they don't specify how long it takes them to do a fix, and then you have 3 to 5 working days for vendors to deal with it. So they're basically allowing the vendors to plan an upgrade, but not to deploy it, fundamentally during disclosure time. And this is pretty much it. I ran over a little bit. There is a long version of this talk. If you're interested, have a look. And, and questions.
Thank you, Lars. Thank you.